So this lesson is about relative atomic mass. Okay. Now what we're trying to figure out in this lesson is, what does relative atomic mass mean? What does it mean? Now, we know that the mass of an atom comes from the number of protons and the number of neutrons in the atom. So let's just take a couple of elements, okay? Here's hydrogen. And hydrogen has 1 proton and 0 neutrons. Okay, so it has 1 proton and 0 neutrons. Let's forget electrons at the moment. Electrons you can kind of add to protons to make exactly the same mass of a neutron. Okay, so the next one we have carbon. All right, and carbon has 6 protons. It's element number 6 in the periodic table. The number of protons indicates the atomic number. And it has 6 neutrons in the carbon-12 isotope. We're just talking about the carbon-12 isotope, and that has 6 neutrons and 6 protons. Okay, so where does that get us? Well, that means that hydrogen has just 1 mass particle. All right, just 1 mass particle. Let's just get this proton up here. Carbon, on the other hand, has 12 mass particles. Now, for the purposes of this thinking, the mass of a neutron equals the mass of a proton. Now, a proton is slightly lighter than a neutron, but we don't count electrons. So when you add a proton and an electron together, you get practically the mass of a neutron. Now, there's quantum physics involved in that, and the masses aren't exactly equivalent, but the bottom line is it's near enough. Okay, so the mass of a neutron equals the mass of a proton for our purposes in calculating relative atomic mass. So if the mass of a neutron and the mass of the proton are equal, therefore carbon is 12 times heavier than hydrogen. Okay? Yep, 12 times heavier than hydrogen. And what does that mean? Well, that means if I weigh out 1 gram of hydrogen atoms. Okay, I just take some hydrogen and weigh out 1 gram. Now, this is not easy with a gas, but just go with the flow at the moment. Let's drop the temperature to absolute 0, and we're just going to weigh out 1 gram of hydrogen atoms. They'll be solids at that temperature, maybe. Don't know. Maybe they will not be. I don't know. And 12 grams of carbon atoms. Now, what does that mean? Well, what that means is if I've got 1 gram of hydrogen atoms and 12 grams of carbon atoms, that means that the number of hydrogen atoms I have here is the same as the number of carbon atoms I have here, because carbon atoms are 12 times heavier. So if I take 1 hydrogen atom and 1 carbon atom, the carbon atom is 12 times heavier than the hydrogen atom, right? So if I take 1 gram of hydrogen atoms and 12 grams of carbon atoms, they'll have the same number of atoms in each sample. Or to put it another way, if I take 1 gram of hydrogen atoms, how many grams of carbon atoms do I need to weigh out to get the same number of atoms as I have in that 1 gram of hydrogen atoms? And the answer is 12 grams of carbon atoms. Now, this little bit of thinking about relative atomic mass confuses an awful lot of students, and it takes them ages to get their head around. But once you've got your head around this, chemistry becomes so much more simple. Okay, so in this case, if I weigh out 12 grams of carbon atoms, I have the same number of atoms of each of these elements. Okay, now let's forget all the details, because hydrogen I only get as H2, carbon I can get as pure carbon, but 1 gram of H2 will still have the same number of hydrogen atoms as 12 grams of carbon atoms. Okay, so the point is that it somehow is hard to get your head around, and a lot of students really struggle with this. But all what you have to remember is that because carbon has 12 mass particles, hydrogen has 1 mass particle, carbon has 12 mass particles in its atom, that atom is 12 times heavier than that one. So if I was to weigh out 1 gram of carbon atoms and 1 gram of hydrogen atoms, I would only have 1/12 of the number of carbon atoms as I have hydrogen atoms in this sample, because the hydrogen atoms are lighter, therefore you get more per gram, right? You get more per gram because they weigh less, right? It's a bit like saying if you're going to weigh out 100 pennies, 100 pennies will have a certain weight. Now, if you weigh out the same amount of pound coins as you have pennies, so 100 grams, let's say I've got 100 pennies that weigh 100 grams. If I weigh out 100 grams of pound coins, and they're 12 times heavier than pennies, I'll not have 100 pound coins, right? I won't have that. So I have to work out the difference in weight between pennies and pound coins before I can weigh them out and get the same numbers. Banks use mass of coins as a method of counting them. Now we use the mass number of the atoms as a way of measuring them, but we can't just weigh out one hydrogen atom, because we can't work in scales that small in terms of particles. What we can weigh out is 1 gram of hydrogen. And then I know that carbon is 12 times heavier. So if I weigh out 12 grams of carbon, I will have the same number of atoms in this sample as I have in this sample. Okay, so that's the way relative atomic mass works. Now, I understand everybody finds this really hard when they first come across it. It seems simple once you've got the hang of it, and once it clicks in your head, it seems simple. But up until that point, it just seems really weird and strange, but it actually works, okay? So, for example, if I want to make myself some methane, have I got a bit of room down here? CH4 is methane, right? If I take 12 grams of carbon, okay, and I take 4 grams of hydrogen, okay, because I need 4 times the number of carbon atoms. So I will get 4 times the number of hydrogen atoms here as I have here. I will end up with 16 grams of methane. All right, there's one to conjure with.